Okay, back to full screen, yeah? Okay. Okay, so bear with me. I know we've seen these same graphics again and again, but we're building a story here. Um, Today, you are most familiar with a language like C, where you take it, you turn it into ones and zeros, and that runs directly on the processor. I imagine you will agree with me when I say C is hard to use. And even if you've mastered the syntax and don't mind the clunkiness of having a compiler and dragging it over the embed and doing that whole piece, I would still say it's particularly hard to use well. And for example, when we talk about data types, what a hassle. When you say, hey, I need a number, you have not only have to think of what you're going to do with that number, but what kind of number is it? Does it have a fractional component? And if so, it needs to be a float. If it's a whole number, how big would that whole number be? If it's quite large, like if you need a variable to hold the population of the United States, then you need something larger perhaps than just an int. You might need a long. And it depends, and how big an int can be depends on the type of hardware. So that's a major headache. It's important if you want to make sure your code is as fast as possible and as lightweight as possible, right? So if you're really optimizing things, something like C gives you a lot of tools to do so. But if you don't really care, you just need a number, what a hassle. Why do we need to declare these types? Also, memory management. If you have an array, we talked about arrays a lot in C, you have to declare those up front, and if it's got 4 elements in it, so it does, right? You can't add a 5th element or remove an element without much more sophisticated tools. So all of these things cause C programs to be difficult to write, and even once they're written, they're hard to debug because there's no way to pause an embed, at least using the tools you have, in the middle of its execution and say, hey, what is the value of X? Where am I in this loop? So wouldn't it be nice if we had a way to pause our programs and poke around inside of them while they run and figure out what's going on? So the big question, is there an easier way to write programs? And of course, if I pose a question like that, the answer better be yes. It would be kind of sad if the answer was no. So we're going to move away from from compiled languages to interpreted languages. And you've already seen interpreted languages like MATLAB. We're going to be using a different language called Python, and I'll talk about why we're not using MATLAB. But let's first look at what is an interpreted language? What does this mean? Okay, so still there's no change. The computer, whether it's an embed or your laptop, can only execute kind of code expresses ones and zeros. So this is unchanged. We still need a compiled, we'll call it a binary, to actually run code on a machine. Right, but rather than using, let's try this laser pointer here. Right, so this is going to actually run on the machine. So rather than writing our code directly in something like C, what if we write a program like the middle here? So let's look through this. We have an int main. We still have a while one. That's familiar. This printf puts out 3 carets in a space, and then who can tell me what scanf does?
It takes a value and assigns it to a variable.
Right, and so there's some kind of C-isms here. We're using %s to say it's a string, and this ampersand to put it in the value, in this variable code. I've omitted some of the declarations that you would need to actually run this, but hopefully you get the idea that you could imagine writing this code in C. Right, we're going to prompt the user for something, whatever they type, and once they hit enter, everything they type is going to go into this value code. Okay, so it's going to be a string. It could be, hey Bob, or A B C D E F G, or maybe something more sophisticated like print parentheses hello world. Okay. Then I'm going to call a function called Python execute. Whatever. This could be called Greg execute if you made a language and called it Greg. But you're going to pass it a single parameter, the code the user wrote or the string the user wrote. And you're going to do something, and you're going to produce a result, right? Some other string which we're going to display. And then we're going to loop back. While 1. Here's another line. And so this is exactly what's happening in the command prompt when you run the Python program. Right? Python is compiled for your machine, and that's why you had to go through and find the x86 version or the AMD 64 version. And if you were on a Apple machine, you'd have to find a different binary that would run Python. Okay, so the important point here is that you can design any kind of programming language you want, right? All you need to do is also make a corresponding function, Python execute, that can figure out how to interpret that code and do something interesting. So what we can do is totally relax the constraints of C and anything else that C is associated with and make our own language from scratch. And since we're doing it in this way, as long as we provide everyone that wants to use our language with a interpreter, we'll call this box an interpreter. Once you write programs in the Python language, you can just give anybody this text file and they can run it on whatever hardware they have. Okay? And so that makes our code portable. Because it's not executing directly on hardware, right? It gets interpreted by the actual compiled program, python.exe. Does this make sense? Let me see your faces. You know, I can't see your faces right now, and I don't know how this is going. So this is kind of a critical concept here. Interpreted versus compiled. What do we think? I got a thumbs up from Davis there.
Sir, can I just ask one question?
Please.
Do you mean that like all you need to run it is a command prompt? Like, because MATLAB, obviously you need the program MATLAB.
Right.
Is that what you mean by it's portable, or?
You need so there's two, with an interpreted language, you need the interpreter. And the Python interpreter is python.exe, and that doesn't have a visual interface to it. And so we run it from the command line. MATLAB is the MATLAB interpreter, and you have to and that is a visual program. There isn't a command line equivalent to it. So you would first open up MATLAB, and then you'd blop in your text and press the play button or something like that. Okay? And so the .m file is portable. You can run on any machine that has MATLAB, whether that's a Macintosh, an OS X, Apple laptop, or whether it's a Linux box, or whether it's a Windows machine. Each one of those machines has to have its special version of MATLAB, right? There is a Linux version of MATLAB. Okay? And that, I think, brings up the important point. Why are we using Python instead of MATLAB? Well, Python is designed to be a general purpose programming language. It is designed to be to allow you all the same capabilities as C or lower level language. Okay, with as little kind of friction as possible. MATLAB is designed for matrix calculations and simulations and math generally, and so that programming language is designed to automate those aspects, right? Rather than being a general purpose programming language. Over the years, MATLAB has added all manner of hooks, including like serial communication. So all of a sudden, we start using it with hardware. But it doesn't do it well. And maybe you've seen that, right? At least in 200, everyone's like least favorite thing to do is try to make a serial object, right? To the point where I just put on every exam. Everyone always panics. Okay, whereas we'll find in Python, it's trivial to make a serial object. And guess what? It actually works. And there's really, so that's why we're going to be spending the time to learn this new programming language. And I know I'm beating this again and again, and it's only because I got it. If you already know some programming languages, why do I have to learn a third one? Like, are you just, quirky, Dr. Donald, because you like Python and you think we should too? And the answer is no. That this is really the Swiss Army knife of programming languages. C is particular. It's a niche language, and it's designed to run fast on an embedded system. It's on physical hardware. MATLAB is a niche language. It's designed to be the best math simulation language around, and it is. It's great. Python is a broad spectrum language. You can do pretty much everything with it, including both ends. You can run it on hardware. It doesn't go great on hardware. And you can run it with versions of MATLAB. Like, you can get libraries to add to Python to make it look like MATLAB. All right? So if you're going to know one language, I would say it's Python. And that's great, because now you're going to know it.
Sir, can I ask a conceptual question?
Please.
So, like, the difference between, like, C, the interpreted, and compiled is, like, Python is just, like, words on a page. Mm-hmm. That's why you can run it in, like, iCharm or Notepad. But then the interpreter looks at the words and then kind of, like, makes that into a compiled language.
Right. And in the same way, C, you can write C in Notepad, right? Okay. But how does C turn into something that can run? C, you have to run it through something called a compiler, which is a program that takes the text in that document and converts it into the ones and zeros that can actually be placed onto hardware. Right? Now, maybe you're thinking like it's a chicken or egg. Well, how did you write the compiler, right? If that's a program, where did that come from?
Yeah.
And it's hard, right? And that's actually what Admiral Hopper did, right? That's her claim to fame, is making one of the first compilers. Is a tool that allows you to write in a higher level language like C and have it turn into ones and zeros. The first compiler was actually written with ones and zeros, right? They would actually have to sit there and do it at the absolute lowest level, like as transistors, and then somehow this thing they created could actually take in int main with squiggly brackets and do something with it, right? And I feel a little bad. We're starting at the second half of the book, right? The first half of the book was, well, what's below? What is a ones and zeros? When I say ones and zeros, like what does that really mean? And that's the whole subject of what would have been this semester. It's something, like if you really want to Google it, it's called assembly language, and that is the lowest level that actually runs directly on the hardware. And each processor has its own assembly language, and so. Yeah, it is a bit of a curtain I'm going to draw across that for now. But if you hang with me next semester, we can really explore what is the assembly language and how would you write a compiler and all those pieces. Okay? But the interpreted language never goes through a compiler. You always just keep that document and you pass it off, and it's always human readable, right? It's always a .py script, just like a .matlab script. You never get a .bin, right? Remember the output of the embed compiler is a .bin, or that you actually drag across to put on the embed. And if you ever try to double click the .bin, your computer doesn't know what to do with it, right? Because those are ones and zeros designed for the embed. Unless you took Cyber SY something or other and you get a hex editor that pops up. Sometimes people have that installed. Does this make sense? Okay. All right. Okay, so let me tell you more about why interpreted languages are great, in particular Python, and then we'll start trying to write some code here. So let's do this. Okay, we're back to full screen. You can see left and right sides.
Yes, sir.
Very good. I like how you're taking turns responding. This is good. Eventually I'll call on you. I'll pick on you by name here, but I can't see everyone right now, so you're safe. But I appreciate you all rotating around. Okay, so this is how the workflow works, right? We're gonna write something here and then run it. It's less efficient than a compiled program, of course, right? Because we actually have a middle person here that's actually taking the Python code, whatever that means, and then doing something with it, interpreting it, and actually running it on the real hardware. So it's slower. But like I mentioned again and again at the beginning, we've got more hardware than we know what to do with. Billions of instructions a second. We have plenty of time to run this particular code block here. And so we're going to take that efficiency hit in order to have a much friendlier programming experience. All right, so we'll start by playing with the command line. The formal name for this sort of programming or environment is called a REPL. It's a read, execute, print, and loop. Right, so we're going to read user input, execute whatever they wanted to do, print the result, and then loop. So that REPL is, here we go. Read, execute, print, and then loop back. Okay? So that's a nice way to try out a code snippet, generally start to learn the language. But once you want to do a more complicated set of commands, it's a real hassle to type them in every time you want to run something. So in order to be more efficient, what we can do is put all of our code in a text file. Okay? And then rather than just typing Python in the command line, we say Python and then the file name. And then Python, rather than using scanf here, it will actually just take line by line out of the file you gave it and execute it as if you had typed it. Okay? So here I've added a bit more Python code here, and once we start learning the language, this will all make sense. A pound sign is analogous to the slashes in C or the percent sign in MATLAB. It means a comment. Just ignore it. It's for, humans to read. Here's the way we use loops, or one of the ways you can do loops in Python. So we can say for x in the range, 0 to 3, print hello world. So this will run 3 times. All right. A couple things to notice here. We don't use squiggle braces in Python. We use white space. So it's very important that you indent properly. I always stress this to my students in 200. But in C, we rely on braces. And so you can get away with these terrible looking code files where everything's aligned on the left margin or something like that. In Python, that'll be an error. So you absolutely must indent the bodies of your loops or the bodies of your functions in order for it to execute correctly. We'll talk more about the syntax going forward. But my point here is that there's nothing special about the name .py at the end of this file. There's nothing special about PyCharm. It's just a tool for writing files, right? But as you write Python code, you'll quickly, want some, more capabilities than Notepad can give you. In particular, line 1, graphically, visually, looks exactly the same as line 2 and line 3. Wouldn't it be nice for me to get a, different color here? Perhaps put this in italics to indicate this is a human readable comment and not part of the code. And wouldn't it be nice if the word for here was somehow highlighted to indicate that's part of the Python language and not a variable name like x is a variable, right? And so we'd want something called syntax highlighting. That'd be really nice to have. And wouldn't it also be nice to be able to, within this program, be able to run it and see the output rather than have to drop over to my command prompt, which maybe some of you have never realized it's around, right? It would be nice if I could just click the play button in Notepad or whatever the new program is going to be and have that run my code. Okay, and there's a few other things we will want as well. When we put all those demands together, the thing we're requesting is something called an integrated development environment. Okay, or IDE. And this allows us to develop code more, efficiently as far as our time goes. The end result is the same. If you were just a stickler for Notepad, you could do this entire course in Notepad, right? You could do this entire, course in Microsoft Word, I guess, if you wanted. But it would be very painful. Okay, so there's nothing that PyCharm is going to give you that's like particularly secret or behind the scenes here. It's just going to help you be a better, more efficient coder. Okay, so we're going to give it syntax highlighting. It's going to detect errors in our code, and you'll see it'll like underline things with red squiggles. This will be helpful. It will allow us to execute our code, do better debugging. And once we start writing bigger programs, we're going to use something called version control in order to keep track of our changes through time. And PyCharm has a nice way this is built in as well. Okay. All right, so that's the end of those slides. I'm trying to keep these slides sort of short and focused so that if you do want to go back to something, you're not seeing this, 50 thing of slides and trying to sort it out. But that's sort of the motivation and the how of Python. You're going to have to take it on faith right now that it is an easier language to learn and use, but hopefully the next couple of weeks you'll start to agree with me. The structure of the course kind of over the next week is going to be the syntax of Python and writing Python programs, just very simple kind of hello world things. And we'll be using the textbook pretty much through chapter 8. You should be able to just go through that and follow the examples. You don't, if you want to type all the code in and run all the little games, I mean, they're pretty lame, but so don't get too excited. But if you want, if that helps you, do it. I'm not going to say, hey, you didn't make the guessing game or you didn't make the labyrinth game. Learn it how it suits you. I am going to require you to totally understand the Hangman game in chapter 8, and you're going to have a kind of in-class assignment where you have to modify it. I'll say, hey, make it so that you now have 10 guesses, right? Or make it so you can select the difficulty level. And so you'll have to be able to go through that program and be able to understand all the lines so you know where to add a few lines to modify it, okay? And that's how I'll sort of check your initial mastery of Python. Once we know the programming language, I'm gonna actually, we're gonna go like I think it's gonna be a 5-week chunk of building the game Battleship. Okay, so Battleship, it seemed like very relevant to the Navy, so that's why I made it. But I realize you don't necessarily just fire cannons at each other in the ocean these days. But who doesn't know the game Battleship? Who does know the game? Who's passionate about Battleship? I mean, when I think mids, I think Battleship. Okay, Riki's in. Good. So Battleship is a game that hopefully like you said you're all familiar with. We're gonna write it from scratch. I'm gonna give you templates, kind of a portion of the code I'll give you. You're gonna fill in your chunk, and then next week you'll pull some more code from me, and you'll add some code. And so we're gonna work, and what is more similar to production or what you might do as a real program out in the world. That you have portions of the code you write, and then you pull in code that I wrote, and we're going to use a version control tool to allow us to collaborate efficiently. And what you're going to see is how do you structure a big program, right? So this is not just, hey, it's main.c and it's my MATLAB script that is 100 lines and it sort of makes a plot and then it's done, right? This is going to be maybe 20 different files. It's going to have graphics. It's going to have network components. It's going to be able to use USB to talk to your neighbor. So this is going to use a lot of kind of complex pieces. And how do you put together a big program? How do you think about programming more than just, I have this immediate problem and I want to write 10 lines of code to do it? Okay, so we're going to think like a programmer. Once you've built out Battleship, and you can actually run it on a network and have your buddy. This is great for a remote, experience because, you actually need the internet to play Battleship with each other. You'll be able to play Battleship with each other. You'll try to play me. I'm gonna be honest. I'm gonna cheat, and I'm gonna figure out where your ships are, and I'm gonna win every time. So you're gonna have to figure out how to detect cheating and how to prevent it by using types of encryption. And that'll flow directly into how does the web work and how does the web use encryption and what does all this mean? And so the next chunk of the course, after about like 8 weeks, we'll move to the internet, and you'll start to build out your own website. And eventually, I'll give you your own server in a data center in Northern Virginia. So you'll actually have a box that is on the World Wide Web, like the big old internet. And you'll see people from all over the world coming at you, and all manner of stuff maliciously. Very few people just want to visit your website and say hello. Most of them want to know if you're using default passwords or if you don't have patch software. And so we can actually watch in real time as people in Syria try to log into your machine and gets 15 different common passwords. And so security is a big piece. But we'll figure it out so that then you can have a nice, safe little website. You can have your friends wherever they're at post their comments and messages, and then and see it all populate in real time. So I think this will be a pretty exciting workflow. If there's at any point though you're sitting there and say, man, all 9 of us, because there's only 9 of you, we're all what we need to know for our capstone, or wouldn't this be cool? Let me know. I am, if anything, flexible. If you have interest in the material, that's so much better than if I'm just throwing something at you and telling you to memorize it. Please, over the course of the semester, if we're going too fast on a topic, we want to really dive into it more, or we're going this way, go that way, please let me know, and I will talk about anything you like. I do a lot of stuff, so as long as it's not totally out of left field, I'm sure we can massage into the curriculum here. Okay? Good? All right. So that's enough kind of, soft in the air stuff. Let's actually write some code here and see if we can start doing some interesting things with Python. So since we don't have the glorious PyCharm set up yet, let's just use the REPL, use the command prompt, and start writing some code here. I'm going to switch over. Let me know if this is visible to you. Oh, give me 2 seconds. I went through all this work to uninstall Python on my machine to all right. Well, I am going to use another tool while this is installing here. Sorry. While you're waiting for me, please go ahead and from the Software Center, go ahead and download that Conda program, Anaconda. It should say Python something or other Anaconda from the Software Center, and get that. We won't go through it today, but given that I've got to do some stuff on this end, go ahead and start downloading that. Okay. I think we're good. So let me share my command prompt here. Is that legible, the size of the text and everything?
Yes, sir, that's good.
Great. Okay, so the first thing I want to do is just run some assignment operations. Like, so let's say x equals 2. Okay? Then I can just say x and I get 2. So this should look MATLAB-y to you. It should not look like C. It should look like MATLAB. But why? Why should it look like MATLAB more than C? Jack. Or if not Jack, someone else.
You're just like entering a variable, so it's just gonna give you an output for your input and after you declared it.
Right. Well, and because it's an interpreted language and not a compiled language, right? So I don't worry about typing my variables here. I don't have to say, x could be equal to 2.5, and that's just fine. Okay, x could be equal to some ludicrously large number here, and that's just fine. Okay, so I do not need to declare my variables before I use them. I do need to initialize them, of course. I can't say x equals y plus 10 because I've never defined y. So I've got to initialize them, and so we call this step initialization, when you set a variable equal to a value. Okay, now I think it's also important to remember in programming, the equals sign is different than in math. Okay, in math, equals is like a seesaw. Like the left and the right sides are balanced. And so there's a symmetry that if you flip and say 200 equals x, then somehow that's the same as saying x equals 200. And that's definitely not the case. Okay? What's the problem with this statement? Go ahead and type it yourself. Like, have a command prompt open and just try these things out.
Like 200 isn't a variable.
Yeah, there's for programming, we're going to use that same horizontal, lines, one on top of the other, to indicate assignment. It's an arrow. If there was an arrow on the keyboard, I suppose we'd use that, but we don't. So a lot of the programming, syntax is just a result of what keys are already on the keyboard. So think of this equal sign not in the math sense of equality, but more in terms of assignment. I'm assigning the right-hand side to the left-hand side. And who am I to redefine the number 200? Right? What a arrogant move. It simply won't work. Okay? Cannot assign to a literal. That a literal is a fixed quantity. That's just a sort of a technical term for it, right? I can also change the type of x on the fly. What if I say look at that. How cool. Right? X is now a string. A string is a sequence of characters. In C, the strings, I don't know. Oh, they're a mess. They're a total mess. Okay? They're an array, and you've got to worry about null termination, and it's a mess, right? I love it. We'll talk about it if we want, but it's a major mess. It's so nice to sit here and say, now I'm a string, and even, oh wait, look at this. Now I am a longer string. What? Just like that, I get more space. I don't have to pre-allocate and say, hey, I want a 100, element string, and if I go over 100, what do I get? What happens in C? I mean, maybe you don't know this. What happens if I say, hey, I'm going to accept some user input, but I only have space for 10 characters, and Maria here has a 15 character name?
You'd get an overflow error.
Yeah, I mean, I think the only reason I'm bringing it up is because I think they cover it a lot in the cyber class, but you get a Stack Overflow, right? And so if it wasn't actually, Maria didn't put her real name, she put Maria / a bunch of special characters that can be translated to ones and zeros that are particular to that machine that allow you to get total access to it. You can all of a sudden take over the whole thing. What a total disaster, right? We don't have to worry about buffer overflows or stack overflows in Python. It just doesn't happen, right? Because I'm never actually executing anything on hardware here. There's another program, Python.exe, that is very concerned about buffer overflow and all that stuff. But guess what? It's compiled and it's done and it just works. Okay? I can use arrays here. Let's try this. Let's make a new thing, an array. A bunch of values here. Maybe we'll make it names. Names equals, and then I'm just gonna see, we got Paul in this class. We got the guy, we got Marco. That's awesome. I've got Lenny.
Sir, can you scroll down, please?
Oh no. Let's see. What do you think?
Thank you.
Okay. So I've got, these are all the people in the class. But wait, Greg's so left out. Poor Greg, right? How can I add an element to this array?
Can you say names equals names plus, and then like whatever, like Greg or something?
Let's just try it. Okay, so it looks like we can't do exactly that. This is why I think it's great that we can use something like this REPL, where we can just play around with it. It's not just like you're trying to memorize a slide deck and saying, okay, I guess I'll try it out later. What we can do is add two lists together. So we're not going to use the name array in Python, because what a weird kind of, I mean, if you talk to somebody outside of engineering and say, I have an array, they'll say, what is that? I have a list. I mean, list is so much more human, right? So we're going to have a list. And I can add two lists together. If you take, one list and add another list, you get a longer list. Okay? So here it was just, one item. But if I want to add more, right? So here, a mathematician would panic, right? I want to just again emphasize this point. There's no way that this list is the same as that list plus more, right? The left and right sides aren't balanced in any manner of speaking, right? What I'm doing is taking the current value of list, which is right here, okay? I'm adding more to it, and I'm storing that combination, now this bigger list, back into that variable called names. And so now when I say names, it's bigger. Okay? And so whenever you're thinking like, how would you do that? When you're writing this program, when you start writing Battleship or Hangman or anything else, you might be sitting there like, God, I cannot remember how to add more elements to a list. You can certainly open up a textbook or start Googling, but I would encourage you to just have a little command prompt open and try a few things out. What's the worst that could happen, right? You get a syntax error? Yeah. So play with this. This is a great tool. So here we have assignment operations into variables. So x equals 20. X can equal names.
Or is there any sort of maybe not like debugging, but reference in PyCharm? Like in MATLAB, obviously, if you make a small error, it'll show you the error. You can click and say, oh, I just needed to add this or whatever.
Yes.
Anything like that in PyCharm?
There's exactly that in PyCharm. And that's why we're going to use PyCharm, right? And so maybe it's good that we aren't diving right into it, because hopefully you'll get these kind of pain points like, okay, I got it, but it wouldn't be nice if there was a little info sign next to it, like click here to learn more, or a green squiggle underneath that said, hey, this doesn't look quite right. And that's exactly what you'll get with PyCharm. Okay? Good question.
Sir, is there anywhere that like lists all the variables you've initialized? Like in MATLAB, it kind of has that list of all your variables. Is there anything like that in Python?
So that's really where the ideology or difference between MATLAB and Python, right? When you use MATLAB, you think in terms of a workspace, like you're doing some kind of work, right? It's like a calculator, right? And you're keeping track of things, and you're coming back, and you're trying something else out, and you want to go and edit something, right? And so think of MATLAB like a really fancy calculator, right? And Python, while structurally similar in terms of the syntax, has a very different mindset. Python, you should think of in terms of, I want to write a program. And that program is going to execute, and it's going to do something awesome and be done when it's done, right? We do have the ability to, in this REPL here, poke around and try some things out. But this is really not the primary way we use Python. In fact, I would say, beyond this first few lectures, you'll just never, and I want you to use it as a tool to learn, but no one is out there running Python this way. They write a program and run it. And so we don't have this, you could think like there's no reason you can't write a version of this program that has a workspace on this side, but we just don't do that, right? You can see, I don't want to confuse you. There are ways to see what's been initialized, but they're just not kind of normal Python work. All right. But good question. All right, so let me, let's see. Let's just do one more thing here, and I want to try a for loop here. Wouldn't it be nice? So I've got this list called names. Paul, Marco, we go on and on. I would like to greet everyone, maybe by saying hello and then your name. Okay. So in C, we had that ability to do formatted output, right? We had printf. And I'm not going to ask you to raise your hand, but I expect that everyone hates printf, or you should, right? What a mess. Percents, and if you want to, do these, you put all these commas afterwards. It goes on and on. So, and I apologize, right? We actually have something very similar in Python, depending on how sophisticated you want to do your outputs, right? But let's ignore the capabilities of print. We have print, right? Hello world. It turns out we can do a little bit more here, right? So that says hello world. Let me just write this and see what you think. For name in names. What do we think? So this is a for loop. And try it. Type this yourself. Right? If you haven't followed along, give yourself an array called names and put a few things in there. Okay, and so what are we doing? We're saying, I've got a list, names. I'm going to make a local variable called name without the S. You could call it anything you want. You call it X, but it makes sense to have a singular here. And name is going to take on the value Paul, then Marco, then Lenny, then Greg. And so this is similar to the MATLAB syntax for a for loop, where you'd say for name equals names. But I like the use of the word n because it just makes more sense. And then I'm going to hit space twice to indent. If you don't hit space twice, you'll get an error because we must indent. And don't forget this colon. And then print. And then inside of print, the actual parameter I'm passing to print is still just a string. But I'm relying on the ability of Python to add. You were going to use this plus sign again. But now the left and the right side are both strings. In which Python will say, oh, you know what? I do know how to add two strings. I just stick them together. It didn't know how to add a list plus a string. All right, I wasn't able to add names plus Greg because names is a big list and Greg is just a string. There's not a rule for that. I know how to add lists together, so generally I can add, similar data types together. So I can add the word hello plus the first element in names. Okay. Just like I know how to add two integers together, but maybe I don't know how to add integers plus strings. Okay, so I guess I'll go ahead and stop here. Please start working on that textbook. I will give you more kind of syntax guides and stuff, but there's nothing that beats just you hammering at it yourself, and coming to me with your questions rather than me just saying, and here's how you write a function, here's how you write a statement. So please start working on the textbook. It's available online. You can order it as well. I would recommend getting a paper copy. And then come with your questions on Wednesday, and we'll go from there. All right? Any questions right off the bat? Okay.
Sorry, I got a question, but it's just kind of specific to my situation.
Okay. Well, if you don't have questions, feel free to head out. And I'll see you Wednesday. If you do have questions, stick around, and we'll get it addressed.
So, sir, I was like watching some intro to Python videos and trying to get PyCharm running, but it doesn't like have an interpreter associated with it, so I can't like actually get anything going, if that makes sense. It says actually I can just share screen.
I totally agree with you that you're not going to get. So that's what we kind of took that vote at the beginning of the class. Like, do you want to get PyCharm working now, or do we want to go ahead and just do a lecture?
Oh, yeah.
And
okay.
So I don't expect anybody to have a functioning PyCharm right now. We will do that either on Wednesday, or if not, then in the lab on Thursday.
Okay, I was just worried it was not.
No, you're not behind
okay.
at all. You're not at all. If you're interested and you say, man, this is going to make my day if PyCharm works, I'm happy to step you through it right now. But if you don't mind waiting, we can do it together as well.
I'll just wait, I think. Thanks,
okay, fair enough. Let's see, Marco, Ricky, you guys have questions?
Sir, I was just going to ask you a question about I can't get the for name and names print hello plus name.
Mm-hmm.
I haven't been able to get that to work yet. It says that.
Can you share your screen?
Like expecting an indented block.
Yeah, exactly. So we're not using squiggle braces anymore. You actually have to add space to say that this is what I want to do for name and names. What do you want to do? Everything that you want to do, it needs to be indented by a couple spaces. So when you, if you look at my screen here, I say for name and names, I hit space, and then I say print.
Sir, could you scroll down?
You see how there's spaces here? I actually typed the space bar twice here.
Oh, do those two spaces, they matter?
Yes, they do. Yeah.
And you have to do 2 for each one?
It doesn't matter how many you do as long as it's consistent. So now when you hit enter, notice it doesn't immediately execute. Right? If I wanted to add more to it, like print goodbye, then I do 2 more spaces. Now when I'm done with my for loop, I hit enter without doing any spaces, and that closes the for loop. And once the for loop is closed, the interpreter will execute it.
So how do you control whether or not it executes versus whether or not it just does the ... again?
It's going to do the ... again, but now you see I'm sitting here at the ... prompt, and I haven't hit space at all. So when I hit enter, it's going to be like, oh, you're all done with that for loop. You didn't indent anything more.
Okay. I understand.
Yeah, it's tricky in the REPL, right? It's I think a bit confusing. But once you start writing the Python code in a file, you'll find it's a lot less cluttered than MATLAB, where you have to say end for, or in C where you have to use a bunch of squiggle braces. Yeah, it's a little tricky. But...
Okay, I understand. Thank you, sir.
Great.